So let's say we've got two objects. Right, and we can, a simple one to pick is, let's say we've got a mass m, and it's above the Earth, and there's no air in between, so we neglect air resistance, and the mass and the Earth is our system. So we now have two things in our system, a very large object called the Earth, and a very small object that we just call m. Now we know that there is actually a force of attraction from the Earth on this object, and we will call this an internal force. So any force between the objects in our system is an internal force. This will become important a bit later on. Internal force. Okay, so this mass is, say, a certain height h above the Earth, and by virtue of its position, it now has the potential to gain kinetic energy. Because the higher above the surface of the Earth this object is, the larger the distance over which it can accelerate, which means the larger its final velocity can be. So we can calculate, for example, what would be the work done. So what is the work done by this force Fg? So, well, we know that work done is always a force dot a displacement. In this case, it's just the magnitude of the force Fg times whatever the height was. We know Fg is equals to m times g times h. So in this case, the work done on that mass is m times g times h. So if it had a velocity equals to 0, so we know this then would be equals to our change in kinetic energy as well. So we have that a half mv final squared minus a half mv initial squared is equal to the total amount of work done. It's m times g times h. In this case, it would be a half mv final squared, because that is assumed to be 0 in this specific case, m times g times h. So we see that the higher the object is initially, if we make h larger, we also increase the kinetic energy that it can gain. So this now is the idea of potential energy. It's a measure of the amount of energy object in a system can gain by virtue of its position relative to other objects in the system, in this case the Earth. Right, so the moment we look at more than one object in the system, these objects can interact with one another. We have to take into account that just by virtue of its position, one object can now gain kinetic energy, or has got the potential to gain kinetic energy, because of some interaction with another object in our system. And we define this amount of energy that the object can gain as the potential energy of the system. It's like the potential of this object to move.